So this is the IDE of M5Stack. So what you do is you have a setup, and you need to first connect your device to the. So this is the M5 ATOM. Let's go to the microscope. So this tiny device. It's hardly readable. Like this. Add some light to it. So you see on the back there's 5 pins on the left and 4 on the right, and yeah, different GPIO ports, a 3.3 volt pin on the top left, a ground pin on the bottom right, 5 volt pin on the pin above, and there's like GPIO 21 and GPIO 25, and there's 22, 19, 23 and 33 on the right. If you look here on the inside, this is a grove connector, and a grove connector is like a simple connector with a few wires. So it's like a black one on the left, there's a right one next to it for so there's first ground and 5 volt and then 2 GPIO pins, and they can figure as both a UART pin and a I2C, or maybe like a GPIO. So if you have any questions about this thing, just fire them off in the chat and I'll try and see if I can answer them. So this is a device, I got it from RefSpace, and it features, it's quite bright, RGB LEDs, 25. So it's a 5x5 matrix. And I did not do anything yet. The only thing that I did was configure it using connecting it to my home network. Let's see if I can show you something. So I'm firing up PuTTY. I'm connecting it to COM port 3, since that is the port that the serial port that it creates when you connect it to the USB-C cable. I set it to 115200, and let's press anything, see if something happens. Press reset. So now it will show some information. Let's change the settings. This is on my other screen, so I need to like create a large font for you to be able to see it. Apply. So here you will see, then I need to set it to the screen mode. So it states API key is 960B423B. So I'm going to copy this, and it starts in MicroPython. And what you see here is if you go to the website flow.m5stack.com, you will be able to copy the API key, and you will be able to connect to it. So it seems connected. Let's try to reconnect. Yeah, and here in the top bottom you will see like a green connected and the version of the devices, so which firmware is connected to it at this moment. I hope you're able to see the device itself too. Okay, so we're going to try and program it. So this features a setup, so I can enlarge the screen. So what I can do is go to the hardware. So this contains an IMU. So you can get coordinates of this device. So X, Y, and Z position, and there's an RGB. So this allows you to either set a single dot to a certain color. So uh, let's do that. Set the one. So we're going to add this and make it a little bit smaller. So this is set the one to RGB red, green, blue. So let's take a red here. So just like HTML colors. So I'm setting this to 255. So somewhere a dot on this device should go red now if I start and run this. Let's see if this works. Executed successfully. Well, okay, that didn't work. Set the one art, red, green, blue. Yeah. Was expecting it to have a pin, but for some reason this does not work. So let's get rid of this one and take this one. So this is the matrix, and I can set my own colors. So set red to 255. Press enter, and you see that this one is where you paint. Come on. The matrix. So I'm setting this one to red. Code entered successfully. Okay. This was not what I was expecting. So let's disconnect and connect. So this is always Murphy's Law. Everything is blue. That's my putty screen. Restart. Come on, you can do it. Connected. So I'm uploading this code. And now we have a single dot. So it was not connected correctly. So let's try it over. So taking the other one, set a single one to a specific color. So I'm setting this one to blue. So 255, and I'm uploading it. And now I see a blue color on the device. So switch to microscope mode. So this is 1. So what happens if we set this to like 6 and upload the code again? It goes down a small step. So yeah, this is like a simple drag and drop feature. So there's like 3 ways that you can program this device in. It's either Blocky, and Blocky is a Scratch-like development environment. But you can also use MicroPython, and the cool thing is that if you design something in Blocky, so let's go to screen. So this is designed in Blocky, and if I switch to Python, you will see how this looks in Python. So you can design something in Blocky, switch to Python and alter the code, but you can also use like the Arduino IDE and just programming it in C. So like for the ultimate starters, you can graphically design it, just like you would do your Lego Mindstorms. You can also use Python, and they use Python a lot in schools, but you can also go full mental on using C libraries and everything else. So let's keep it as basic as possible. So let's yeah, design a image. So what can I do? Let's get rid of this one, go to RGB, select the matrix, and I'm selecting green, and I'm selecting 128, which is like dark green. If it was 255, it would be light green. And let's see if I can, for instance, make something Minecrafty. This looks a bit like a Minecraft creeper. So press run, and now you see the alignment. Let's. I need to somehow tape this to the desk. Use this one. So can I zoom this a little bit? So this is green. I can make it full screen. Microscope view. So this is what we did. So you can also use multiple colors. Like I'm from the Netherlands, and the Dutch flag is red. So that's 255. Enter. Now I'm drawing like red. And the top one is blue. Let's create a darker blue. Will this work? Let's see. So blue and white. White is 255, 255, 255. And I can just draw white. And now you see it's still green. So I have to run this first. Come on, you can do it. Yeah, red, white, blue. So let's create a dice. So my kids really enjoy. Are you able to hear me, by the way? Our kids. My wife corrects me. Can you reply in chat if you're able to hear me? Or did I somehow select interaction on this thing? No chat yet. Yes, thank you. That's so. What I need to have is there's a button on this device, so I can click it. So what I can do is I can create different structures. So let's say I start this device. Thank you. Thanks. By using this one. So we're starting with like a white screen, and now I'm adding logic, and logic is like a conditional possibility. So the condition is if something happens, do this, and else do something else. You can program each slide, and that's actually what we're going to do. So that will be fun. Will be fun. So let's use two others. So I can either go here and just drag another one. But what I also can do is just click it, Press Ctrl C. Oh, let's switch to the bigger view and press Ctrl V, and I will have another one. So now by default it will be white. If I'm not clicking it, then I don't have to do anything. So only if I click it, it will do something else. So let's make this a different pattern like this. So make a Commodore 64 logo, for instance. So what I'm going to do now is add an event, I think. So if A was pressed, so if A, so it starts, the screen is entirely white, and if button A, which is the button on the atom, is pressed, it will show this one. So let's run it. You could actually hook it up to a Raspberry Pi. Why your icon is pink, I don't know why your icon is pink. But there's I2C, so you can connect I2C communication to the Raspberry Pi. You can also use the serial port to connect to the Raspberry Pi. And back in the days, I used to teach young children by using a device based on the Raspberry Pi and I2C. So it's white now, and I'm pressing the button, and actually nothing happens. So this is very cool. So why is nothing happening? Maybe I have to press it? No. If A is pressed. Setup. Let's see, there was something else. So I did not prepare this in any way. That's like the most real experience. So there's another one. So except for the setup, there's also like functions that work outside a loop. So this is the normal one. So it starts and sets it to a white screen. And there's another function that just waits for the A button to be pressed. And we can see how this was done. So this is a button that is defined. There's a small overhang on the door. Okay, so go back to Blocky, run it. So it's done, press it, and now I will see the logo. So yeah, only works for one. It would only work if you press it during the setup. Yeah, you're right. Yeah, thanks. So this will be external. So let's try to make a dice. So what I'm going to do is I first need to have somehow a variable to run this, and there's different ways we could use, like for instance the IMU to see how you shake it, but let's use a random integer from 1 to 0. So this is a function inside M5Stack that allows you to create a random value. So what I'm going to do is using the same events. So if A was pressed, then I'm using the RGB. So a random integer, and this is like the pin. So imagine the light to be a neopixel, a string of lights, which is from 1 to 25. So if I create a value here and take another value, So this will be 1 and this will be 25. So every time I press the button, there will be one dot colored in red. So let's see how that works out. So now it's black, press the button, and this button, this position is red now. Now this position is red, there's another position red. So the same position is red, so I can just press and random positions will be filled. So we use this now on a normal color. So what else we can do is like use this one and so remove this. So if I press the button, any of the dots between 1 and 25 will be filled. And I'm taking this one, copy, paste, put this here, will be, oh, damn. Copy, paste. Maybe I need to make it a little bit smaller. So before I copy it, this one will be 0. And imagine this to be like your HTML tag color. So it's like 255, 255, 255. So it will be a random color between 1 and 255 for red, green, and blue on any of the positions. Yeah, could be Periscope. It did not allow me to stream on full HD, so I had to stream on 720p. So, and I need to like, this is full screen, but to make it able to fit. The cursor lags, that's because I'm old, so I can see where my cursor is. So this is actually the same as it is here. So running this again. Okay, pressing a button. So this one is yellow. What happens? This one is pink, white. So this is like just pressing it. And you will see like all different colors. So yeah, it will be a little bit hard because the microscope is not. Oh yeah, might be scaling it down. Sorry for that. Yeah, cursor trails. That's what I'm using. So this is just to explain. There's a random function inside this language, and you are able to like pick a single RGB LED and set that to a specific color. So the other thing that you can do is create variables. So there's a variable and I'm creating one. So this will be my XKCD random. This is my variable. So I'm taking this one. Set XKCD random to, it should be 4 of course. Taking this one, copy, oh, 1. Oh, it's not connected. That must be 4, yeah, absolutely. So take this one to 4. Yeah, that's what it is. And now I'm creating a loop. So I would like to have a case statement, but the case statement is not possible, I think. So what I need to do is like create a nested if then else loop. So create logic. So this is my if then else. So this is my first one. And now I'm creating the RGB. So taking this one. So if, and now I need a conditional statement. So I need logic. So if this equals that, so let's make this a little bit bigger. So if, and I'm going back to the variable, so if xkcd random equals uh, 1, then I'm setting this to 1, and I am copying this entire structure, so copy, paste, and I'm pasting this into the else. Oh, I need to scale it a little bit down. So this is to the else. So xkcd random is 2. So the reason I'm using the variable is if I'm using any random value inside my if, it might be different in the first if rather than the second if. So I'm creating a variable, set that to a value, and I'm using like for xkcd random now, but I will use a different random later, just for programmers humor. So setting this to 3, copy, and I need to make it smaller. So set this one to 4. So this is 1, this is 2, this is 3, this is 4. So scroll down a little bit, copy. So this one goes here, which will be 5. And finally, this one will be 6. So set this one to 5 and set this one to 6. So yeah. Let's talk to the people behind it at M5Stack. So I'm running this, and this should show a pin on the 4th position that's white. So this works. So now I'm using a random variable. So go to what is it, math? Random integer from. So taking this one, copy here. Take another number. So this one will be a number between 1 and 6, from 1 to 6. So running this, and now it's 1. Running it again, it's 4. So we want to have this interactive. So what we're going to do is create an event. So if the A was pressed, this entire structure will work. And since we're using the matrices, the rest of the screen will be black. So running this. So it's done. Press it. So this is 3. This is 5. This is 4. This is 5. This is 1. This is 6. This is 4. So although you can just count the dots here, it would be more fun to have like a font here so that we actually can read it. And since I'm not that creative, I'm just a geek, I'm using 5x5 fonts to see if someone already creates something that can be useful. So let's just steal this one. So go this one here, and so where are you? Oh, here. So so this is the 1. So 1 will be like this. The 2 will be like this. The 3 will be like this. Scroll down a bit. And the 4, that's quite a cool 4. Like this. 5. Oh, what did I do? 5 will be, no, the other way around. 5 and 6 will be quite a square 6. Okay, cool. So see how this works. Run it. Ah, I need to press. So this is quite, maybe if I do it from a little bit of distance, it's quite hard to read. 1, 3, 5, 1, 6, 4, 1. But you notice that I did not know that I needed to press the button. So we need to make sure that people know that they have to press the button. So let's create something else. So where is my, let's make this one a little bit bigger. So can I, oh, turn the camera, 3 is the other way around. Yeah, good call. So this is not that intuitive. Other way. Yeah. So 3, 6, 6 again, 5, 6, 5. This better? Okay, cool. And we can even say like 1 is white. Let's create this one green. So this is a green color. 1 and this one. Oh. Okay. Blue-ish. Enter. So this is blue. Ah, come on. What did I do? If, else, yeah, still works. So more like a royal blue. And this one, let's make it yellowish. Looks like my I void warranty stickers. Neon yellow. Make it doorbell with it. It tells you if you're home based upon like activity. Yeah. It's like please rob my home.com. There's a Twitter account for it. But you could do like proximity to see if like people are connected to the network, like query your DHCP servers to see if certain IP addresses, static IP addresses are registered. So you could do things like that. So what am I lacking? I think a red color. So red 4. Wi-Fi account, I think burglar or something like that. And it was like initiated when there was Foursquare. Foursquare was the service where you could say that you were entering a building, but like people were warning other people to not do that because they. I've no logs in. Yeah, that would actually do that. But please rob my home.com was like looking at Twitter accounts that told that you were not at home at a moment because you were like signed on to a different location. So if I'm doing this one purple, so it's actually quite fun and it does not require any program skills. A little bit like base loops, conditions, but you don't have to learn like fancy words to do it. So this is 2, 3, 2, 4. So it's different colors now. So am I able somehow? So if I do this, copy, can I? Now I need my font again. So are there any letters to it? So press. Or hit me. This product is called M5Stack, and this is the Atom. So I'm able to. How can I show it? Atom, and it's made by M5Stack, and the M5 stands for the dimension, so it's 5 by 5 centimeters, and stack is because it's stackable. So I have like a box of those. So I created a telephone out of these. It's an ESP32 ecosystem, like the same as the SHA batch, for instance, and the earlier Hotel Hacker batch. And I think this one is only €8, so it's very cheap. It has a screen on top, but there's also like RGB screens. I actually created a proof of concept with a friend, if not Pike, to de-authenticate Bluetooth glasses to be able to create your own text on the device. And I met him by, yeah, it's quite a funny story. I created the phone, and the phone was built using the M5 and a GSM module. And instead of using my real telephone number, I was using two burner phones, and I was demonstrating that it worked. So I was able to use my iPhone to call the device, and the device was able to call my iPhone and was able to hear the other party. And within 1 minute after publishing the video, I got a call from a telephone number. I think it was like 3133713371337, like elite lead lead. And that was if not Pike. And we talked like for a few hours, so we had a lot of fun. We share a lot of interests. He's like very into software-defined radio. So if you do not follow him, it's like a green furry icon on Twitter, if not Pike, and he really does amazing stuff. Currently, he's working on Raspberry Pi with a push to talk button to like broadcast messages over RF. So follow him. He's very cool. So my ID is make a hit me. So copy, paste, hit. No, I'm sorry. You have to open like another device to do that. Hit. Scroll a little bit down. And can I would this work for an M? Yeah. Copy, paste. Then needs to be one in between because we need a space as well. Okay, copy, paste. So now whenever the device starts, it will show hit me. So running this, and if not bike, let me type it in, if not bike, like this. So I made a mistake on purpose. So what would happen if I was to do this? Anyone? Let's run it. So the camera is offset, sorry. I need to alter this to make it visible for myself. Yeah. Now it will be easier for me to align it. So I'm running it again. There is no delay, exactly, there's no delay. So delay is a timer function. So I'm able to add like a delay, and let's use 0.25 seconds. So copy, paste, paste, paste. Not much of a banner, but yeah, will do. So paste. Oh, no, will be on top. Scroll down, and I think I need a hit me, copy, and this one. So run it. Well, that's a little bit too fast, so make it a 0.5. And you can even, there's like a ESP protocol that allows you to make a device like dormant and really low on power. And whenever you start it, it will broadcast to an like a Bluetooth network to be able to yeah, it will boot and it will connect to a server to be able to yeah, do a specific function like a doorbell, for instance. It works very fast. So try this again. Hit me. So maybe do something fun. Create like a loop. I don't know what will happen if I do this, but let's try. Do well. Need to scroll a little bit. Oh, this one to the top, and move this one down. This one in between. While maybe true. Is there true somehow? Logic. Well, true. Yeah. Let's try and see what happens. Hit me. Hit me. Press button. Ah, now it will. Well, maybe I can add the hardware. So any logic. Something pressed. Event. Well. So removing this. While A is pressed. While A is released. until A is pressed. So see what happens. I need a little bit more pause at the end. So copy another one, copy, and make this one like a 1 second delay. Run, hit me, nothing, hit me, press a button. Too bad. That doesn't do anything. So how can we solve this? So we can add another variable. So create a variable. Not pressed. So I have a variable not pressed, so I need to set it. So set not pressed to, now I need logic. So not pressed to true. And what I do is repeat while not pressed. So add the variable. And whenever A is pressed, I can set the variable not pressed to logical false. Maybe this will work better. Okay, run. Hit me. So for the people that just joined, we are programming a M5Stack ATOM brick, which is an ESP32 device using Blocky. So pressing 6, 2. So this does actually work. 3. So rebooting it again, just to test if it works. Hit me and press the button. Oh, maybe it was still booting. A little flaw there. So this is just an example on how to program this. So this is how I made it in Blocky. And by switching to Python, you can see how the Python code looks like. So what you can see here is like there's a def button A pressed, random int. These are the colors that I selected. And this is like the scrolling text that you saw. So actually in MicroPython, yeah, it's a bug. It is in MicroPython. It looks quite simple as well. So yeah, really enjoy this this ecosystem, M5Stack. Yeah, there's a lot of stuff for it. So let me open up. I'm not sponsored by M5Stack, by the way. It only checks. Yeah, that's true. It only checks at the start. So M5Stack. So the store. This is the Atom, and the Atom is actually 8.95, and there's different ones. So this only has a button. So if you do not require a interaction of some kind, you can all. They should be sponsoring me. Well, actually, I think I already bought everything they have in store. I'm such a big fan of this one, and there's some pretty neat stuff. So this one allows you to scan barcodes, so barcodes and QR codes. And this device I got for free from the hackerspace that I'm a member of. It's like a ref space, which is a hackerspace in Den Haag. and let's go to store. So I used to have this one, the core. Where's the core one? So this is the core device, and they come in 3 different colors. So there's like a light gray one, and a black one, and a red one. So the most simple one is the black one, which is $27.95, and this is just an M5Stack and an RGB screen. The gray one includes a 3 degree of or time of flight, 3 degree of freedom sensor to it, so it allows to do some extra stuff. And the red one actually has a different ESP. So this is the ESP-W Room, and this is the ESP-W Rover. So this one has more internal memory, so it allows you to do other stuff, like you can do over-the-air updates. You can create your own file system, and they're using like the Grove connector. So here you see let me show this one. Here you see like the black, red, yellow, white cable, and this allows you to connect like devices. So this is an environmental sensor, this is a color sensor, it's an RGB LED, this is a passive infrared sensor, this is a analog resistor. So you can build your own weather station. I even have a robot. So if you like, I can get it. I need to get it next door. So what else do we have? So this is the robot that I have. It's a LiDAR robot. So it will look at its environment and just broadcast the signal to the receiver. Let me get it. Will be fun. Hold on. So should be here somewhere. Yeah, here it is. And I actually got this as a gift from my colleagues. And that was pretty cool. It's an expensive gift. Here I am again. So this is the box itself. So if you open it, there's like this device, and this is the faces device. So you see here on the top there's let me put that on the webcam view. Webcam view. So this is like a backplane that allows you to connect. So now it has a joystick on the bottom, but could also be like a calculator, a shield, could be like a Game Boy shield, could even be like a turn dial to make it into an electronic volt. And the top has like the simplest M5 stack. So it's the M5 stack W room. So it got like a charger. This one is for the lipo cells to charge them. And this is the robot itself. This is like a epic device. So I hope it will autofocus somehow. So what I need to do is like put on this will work better. So turning the device on, and it will boot, and it will spin like the LiDAR, And now you see like the environment. So I'm putting this one on the table and making my microscope able to somehow see it. Let's see if this works. Can you see my table? Yeah, somehow. So I'm booting up the M5Stack. So on the side there's a button. Let's see if it works. Maybe the power has been drained because it was dormant in the box. So what I'm going to do is I'm going to steal the wire from the M5Stack, charge this one, so it will boot up. And now this is the environment for the robot. So what I'm going to do is I'm going to hold my hand in front of the robot. And you will see it is no longer able to see the reflection. So I'm moving my hand a little bit, and you will see that it's able to distinguish like one-dimensional insights. And I think that this is the same system that is being used in like Teslas to track the whereabouts of the car to prevent collisions. But it can also so move the robot around. So I'm able to see where the robot is heading. So you see, like as a base, this has so much potential. And at the moment that I started with this, it was just lights and switches and temperature and like gaming but I work in cybersecurity. And one of the things that I run into once in a while is like ICS and SCADA systems. So what I would really like to have is uh, um, special blocks to be able to interface with like nuclear systems or power plants or like chemical plants. And they actually adhere to the request, and they made PLC modules that yeah, you could use on in on the special rails. If you want, I can get the rest of the stuff that I have to show you a bit around on uh, what they have. Let me get some boxes. So basically, I have two boxes. Let's see if I can somehow open these without blocking the entire view. Okay. Right here. Are you able to focus? Come on, you can do it. So different devices. So you have the black ones, you have the gray ones, and you have the red ones. So the red ones are more powerful, and the gray ones are basically the black ones with an extra feature to it to create like an XYZ. This is something else they have, and yep, you thought about webcams or doorbells. This is actually are you able to see it? A webcam. So you connect this one to an USB-C connector, and it will spin up a Wi-Fi access point, and you will be able to connect to it and stream video. But since there's like on the bottom is a connector for the Grove, so you can also add a pair to it to be able. I really hate that my camera is out of focus. It's because I'm not close enough. Why is this? Expecting this to work better for the amount of money that I paid for it. So this is the face shield. So the face shield is basically a bottom plate that allows you to connect an M5 stack. It harbors an LiPo cell. So what you can do is, see if you can tear the devices apart. So this is the bottom and this is the top. So I can add this one here. So now I have a device that just has a battery, and there's different things. So this one you already saw. So by adding this one here, now I have a remote control. So I'm able to scroll like left, right, top, bottom, and it has RGB LEDs, so you can even have interaction with those LEDs underneath. Another one is this one, and this will allow you to use it as a keyboard. So you will be able to type stuff, and it is even possible to program in MicroPython using this keyboard. So there's also a piece of software that allows you to play Mario on this device. So this is like a Game Boy Shield. So you have like your buttons A and B, select and start. And for the telephone version, I used this one, which is basically like a calculator version. Able to somehow show the numbers, yeah, a little bit. So it's like a 0 to 9, a dot. So what I did was like use the X sign, the multiplication sign to disconnect, and use the dash to mute, and do some other stuff. So now it's just a calculator. So if I want to turn this into a phone, I need other stuff. Oh, this is another one. It's also very, very cool. This allows you to clone RFID cards. So this RFID, and this is like a vault key, so like an analog turn dial or digital turn dial, and it also has like feedback on the side to show how much you tried. But you can create like an electronic code that will allow you to like 20 to the left, 30 to the right, 15 to the left to be able to unlock something. These where are you? industrial connectors. So this allows you to do Ethernet and RS485, and it comes with like a magnet connection. So I'm able to connect this one to a rail, and I can also make it connect to a industrial rail using these black devices. Can you put your own software on the device and show custom stuff on the screen? Yeah, absolutely. There's even videos that you can play on the device. You can make it like the thing that I showed with the robot showed the whereabouts and the feedback of the lidar. But I created like software to scan I2C network to see whatever devices that were currently connected to the device. And since it is I2C, you can basically connect it to everything. And if you look at the bottom of these devices, let me get one. No. It's has Lego connections, so you could actually let me see, some nuts and bolts. And you can turn them into a watch, for instance, so they have these connections. So one day we went to Comic-Con, and like the LGBT community in Comic-Con is quite large. So what we did was during Christmas, I think, is we created cat ears, and the cat ears were able to like go into Christmas lights. They were able to go into like the gay flag. They were able to go into devil's ears. All different flags were possible, and just like by wearing the cat ears with a small connector under your clothes to the watch, and the watch was actually powering the device and addressing the different lights in the cat ears. This is another device, so I don't know what's on here now. I can. Oh, this one. Oh, okay. So, are you able to see it? So this is a large LED display, which is quite lighty. Is this one? Maybe I need some paper on top to dim the light a little bit. But this is comparable to the Game Zone badge, which is a large badge with a lot of LEDs on top. So, are you able to? So now it states alarm. If I don't do anything, it will stay black. But there's a pair here, so I can activate the alarm. So something else that you could do, like make this into your bed alarm clock, and light it up whenever you just wave your hand, so it will be not lighting your entire room unless you want it to. So let's clean this a little bit up. And the other box that is underneath has like the extensions for all the shields. So instead of just having shields, you also have different extensions, but you can also create your own extensions. So this, for instance, is a CC1111, and it allows you to do sub-gigahertz radio frequency send and receive. So you can build your own modules as well. But they already have a lot of modules. So most of the stuff that is already there. So let me show you some different devices. So I recently bought this one. So this is a Euro connector, which allows you to create a plug, and this contains a relay to switch an AC socket. So this will allow you to switch on your coffee machine using like a special button, for instance, or no, not 4033. So this on itself is just a relay, but entirely NK, so that it is safe for you to work with it. So this allows you to switch AC power using small DC steering power. So you talk about 433. I have some stuff on 433. Let me see where it is. Let me. I don't know if this one, so this is a LoRaWAN shield, so it allows you to communicate with small packages over large distances, and so you stack this on the device. So put this in between the display and the battery, so you stack a lot of these devices, but be careful, since some of the devices. Oh, the comment was about the module with the antenna. Oh yeah, 433, but also 868 and 915. So it's not the entire sub-gigahertz range, but you are able to do a lot of the frequencies that are allowed by like Dutch regulations, and it depends on the region that you're in to see what is possible to broadcast. So this is LoRaWAN, so you actually need two. This was how I created my mobile phone. So this is a SIM card. It's um, SIM 800. So it's actually quite cheap. There's a audio jack on the side, so that allows you to either use the microphone that's on the bottom, this one, or you can create a small bridge on the circuit board. I soldered a small bridge somewhere to allow it to use maybe on the other side. I don't know where it is anymore, but to like use, for instance, iPhone ears to use the microphone in your external device. So this works just like an ancient Haze modem. So by sending it ATDT commands, you will be able to dial a phone number, and ATH will do a hang up and disconnect your phone line. You will be able to send text messages. You will be able, to do whatever you fancy. So if I use this device and I use this device and M5Stack, and I connect those two together, I can even make a SMS enabled switching device that allows you to turn on a device or reboot a device using a cellular text message. What else do I have? So this is a Lego shield. So this allows you to connect different sensors and motors to the device to interface this with Lego, and it is a yeah, it's more advanced at the as the Lego system itself. So yeah, it allows you to do extra stuff. This one is a node module, and it features an RGB ring on the bottom, and on the side there's can I show it like this? Yeah. On the side there's infrared lights. So this will reflect infrared beams throughout your entire living room and allows you to turn on your television or your audio set, or this is like a Logitech harmonic device. So it allows you to mimic infrared remote controls. So this is something that you will mount on the wall to be able to yeah, control your audio or your television or whatever. What else do I have? This allows you to do CAN bus, RS485, I2C. So a lot of different modules. So this allows me to hack a car, for instance. So this allows me to plug into a car's network, create television, to recreate television, like yeah, absolutely. You could do this. So you have to program it yourself. So yeah, not all the modules work as well in the environment that we just use to create the dice. Some of them you need to program in C, for instance. But yeah, you will be able to either take an existing remote control and learn the signals to the device to be able to mimic them. Yeah, there's some other stuff like this is an I2C, and I2C is a yeah, serial protocol that features a clock and a serial connection, and it allows you to create an I2C, I2C, to have a keyboard to type in stuff. Oh, if you don't know C, yeah, then you have to learn it. It's not that hard. So what you can do is install the Arduino IDE and install the M5Stack, and I think I can do another stream on how to program in C. It's not that hard. It is more complex, since you really need to program in a, yeah, that is a good excuse to start learning C, and it's like simple C version, so it's less complex than learning it the hard way. But there's also a lot of ready-made samples that you can use. So you can already use whatever samples they have and just tune those samples. So you don't have to program it from scratch, but you can um, work on existing projects. Yeah, it allows you to do things yeah, very easy. What else do we have? They have like sockets. It is, but there's already a lot of libraries that you can use to make it easy, to make it work like so the question was, isn't it super low level? Within the Arduino environment, it's easy because of the libraries. That's basically the answer. So the libraries allow you to create stuff just as if it was like in the M5Stack Flow So this allows you to chain different modules, and you have a lot of modules. And if you look here, these are actually the cat ears on the side. So let's make this one a little bit bigger. So these are the cat ears. Can I look at the cat ears? No, not right now. And store module. So this is unit, I think. So these are the different devices that you have for it. So there's a lot, and if you look at the price, like $2.50 or $1.99, it's like it's Lego-like stuff, so it's easy to connect them. It's just clicking in a wire like a telephone or network cable. So it's hard to make mistakes, and it's a little bit more expensive than the sensor itself, but it really saves you a lot of hassle by figuring out all the stuff. And so I show some of the devices that I have. So this is like an RGB. So go back to webcam view. Where are you? Here. So this is just three LEDs that you can address using RGB. So you can set light 1, 2, and 3, just like we did with the Atom. But the Atom had 25 LEDs. What do I have here? So this is an infrared. Maybe I can show it. I put this one. Will this work better? It's not that steady. Maybe add some light and go to the microscope view. This works better. So this is an infrared remote microscope. Yeah. So this allows you to receive. The Atom can be controlled in Python, not in Python, in MicroPython, which is a smaller version of Python. And I think that most of the stuff that you can do in Python. But sometimes you run into boundaries if you're going really low level. So this will allow you to do the same thing that the Node device was able to do. This is a pair, so passive infrared. So if you look at the bottom, you power it at 5 volt and ground, and it will give a signal to on what? Give a signal whenever there's activity going on. So this one is light sensor, and you can set it for the sundown, sunset, to be able to switch on and off the lights whenever it becomes dark or light, and you can tune it to your own yeah, favorite settings. Yeah, you can if you have the Atom, like the Atom itself, and and the other one. So let me show how it works. So this is the Atom. This is a Grove cable. I can connect the Grove cable to the bottom here. So this one is connected now. I use this cable. And now I have a M5Stack ATOM that controls an infrared send and receive file for the what was the this one is 199 and the other is 695. So for under 10 dollars, you will be able to create your own remote control. Okay, what else do we have? What is this? So this is a color sensor. So what it will do, and it works using I2C, it's digital. It will broadcast a light, so it will broadcast different lights to determine the reflection of the color. So you will be able to see whether it is green or blue or red or yellow or whatever. You might need to train it. It might require some ideal um, uh, yeah, settings for it. But what you could do is like create a game where you have to apply colored cards to your atom to be able to make it do certain things. Like imagine some elderly people that are fond of specific music. You can just give them a colored card. So instead of needing to program something, they just show a colored card to a machine and it will play their favorite music or tune from the past. So it's another way of communicating. You could also use it like for robots that follow lines, and if there's like, or an M&M sorter, yeah, absolutely, you can do that. And what do we have here? This is like a simple button. So this one has a button, so you can click this, but this also has a separate button. So if you need more buttons, you can just add buttons to your project by using the M5 Grove. What else do we have? This one is a cool one. So this one is a music player with NFC, like in a wooden box. But there's also the Wonder Phone, which is like a old turn dial telephone device that allows you to dial a specific number to listen to an MP3. But the NFC card one was very fun. So what this allows you to do is it allows you to measure your heart rate. So there's two different devices in here. There's an infrared light, an infrared sensor, and if you put your finger on top, it will measure your heartbeat. So it's a heart rate monitor. There's also these things, and this allows you to measure if your plants are in need of any water. So you can just put this into the device and connect it to an M5Stack that's connected to Wi-Fi, and it will send you like a text message if your plants need water. And this is the analog volume button. So this will give you a value either from 0 to 255 or from 0 to 4096, 95 then, to be able to dim certain things. So this is just analog. Yeah, there's really a device for everything. There's so much stuff. It's like totally epic. Extend I/O. So this allows you to create extra I/O pins. So if you have the oh, they are on the bottom. On the bottom of the device, so also here, you see 5 by 4 pins. So these are 9 pins, but you can make it into 19 pins if you add this one to the device itself. So if you need more pins to address certain things, you can have like an I/O, yeah, multiplexer, color sensor. What do we have here? This is a proto board, so this allows you to create your own circuitry here. So if you, for instance, want to make a yeah, like the RF module, you can add it here. So this is how you would solve it into the module way, but you can also solve it using a stack way. So yeah, there's different solutions for the device. This is cool. This is GPS. So it allows you to see your whereabouts. So what you could do is the M5Stack itself, the ESP32, already features Bluetooth and Wi-Fi. So this would allow you to create your own WAR driving device to see where you're at and what the Wi-Fi access points are in the neighborhood, or the Bluetooth access point in a neighborhood, or create your own COVID app using GPS, whatever you fancy. So this GPS. If you want to switch AC, so this is a relay and allows you to switch 230 volt. Personally, I would not go for this solution. I'd rather take this one, since it's more solid, and if you're working with high voltages, yeah, they might kill you. So be safe. This is the thing with two values. So you can, there's two buttons here. Time to use the device. You stuck the joystick up. Yeah, you can actually do that. There's the faces shield. So the faces one allows you to have a joystick, search for different things. Don't know how well it works with the screen and the resolution and the maps, but this would allow you to create like a game. So add a couple of these devices, dual buttons, to be able to have a game where you have to answer with either yes or no. So you can make a game for children's party, for instance. This faces like your face. This is a fingerprint sensor. So you could actually enroll using biometrics. And if you look at the price, let me look at the, I was really, I used biometrics before. Yeah, you could actually do that. And I'm into geocaching, and there's actually the kabouterkaarten that will show the environment in lines. Not here. Two. Fingerprint 1695. For 1695 you have a fingerprint sensor, and you can just enroll different fingers by using this to activate your alarm or disable the alarm or do whatever you want. So that's very cool. What is this again? I actually don't know what it is. Let's look at it. This one. Oh, this I squared C hub. So this will allow you to multiplex different I2C buses. So you will be able. Can you have detect who it is? Yeah, absolutely. Based on the biometrics of the device, you are able to detect either what finger you're using or what person you're using. So what you have is like a certain value per person, and you can just use the same if statement to yeah, do something for per person. Maybe I don't know how late it is. Almost 12. Yeah, and there's some other stuff like for industrial. So this is RS 485, and you can chain those. So this is actually an RS 485, but I can connect this one uh, to this one and loop all the data. Okay, what else do we have? Yeah, there's like funny stuff. Could you make present who leaves the house when they press it? Yeah, present you can do using the passive infrared and by either using the activity. So if you see if there's someone with a specific Bluetooth connection in your vicinity. You will be able to see if someone is here or not. You will be able to see it if they signed on to the Wi-Fi network, but you can also use like fingerprint if you want to do manual presence. And this is like a NeoPixel LED matrix, and you can also chain those to make it into like a larger module. Maybe it's fun to see if we can do something with the fingerprint. So I've not worked on this before, but let's see how far we can make this work. So I now connected the atom using the Grove cable to the fingerprint cable. So let's see if we can somehow make this do something. So I'm connecting the power. Going back to the M5Flow. This is the M5Flow on the left. Waiting for the device to reconnect. It is connected. So I have an M5Flow, and what you see here on the left, so let's put this back to Blocky, is units. So if I click on plus, I can select a certain unit. So what units am I able to add to this? So I can use buttons, RGB, infrared, keyboard, heart rate. I'm not able to do heart rate. AC socket does not work. So thermal. So there's even thermal. So you can do like a heat heat vision. Yeah, it is possible to add the fingerprint. So I'm adding this one, and I only have one port. Sorry, I need to switch screens. Thank you for pointing that out. So I'm going back to this one. I'm canceling this. So I'm doing this all over. So let's remove all this. So delete. Delete. So I have a blank screen now. So this is the M5 stack. the M5 Atom, and I'm using the plus sign to add devices. So here on the side you will be able to switch between the different modules. So RGB, but some of them you cannot use. Like I'm not able to use the heart monitor on this device for whatever reason. Maybe because it uses the same IDs as the button on the device. I didn't save this one, but I did save an earlier version. But I thought instead of opening the sketch, it was more fun to build it from scratch to take you through the entire thought process. So a heart monitor is not possible, thermal is possible, GPS is possible. So this is the fingerprint, and fingerprint is possible. So if I click on this box, am I able to? No, where's the fingerprint? Fingerprint. If I click on this box, I can select a port. And since I used the Atom only has like one connection, whereas like the Fire has three connections, and the base have only one, I think. So I'm connecting it to the A. So I should have a extra possibility here. Units. Again. Where are you? Fingerprint, select port A. Okay. Ah, and now you see the fingerprint here on the bottom, and there's like finger here. So there's, oh, I have no idea what I'm doing. I'm just doing this for the first time. So finger get state, finger remove all, finger ID 1, remove finger ID 1, delete user finish. So I first need to enroll myself. So let's first remove all the fingers from this device. Finger removal. And then add user ID 1, access 1, 2, 3. Let's Google how this works. M5 finger print M5Flow. Maybe some images already with schemes. So what did they do here? Oh, this is a video. Let's just steal someone else's ID. Well, this is not going to work. Just see what happens. Finger add user ID access 1. So I need somehow to see, so I need to create an if structure. So if that's a piece of logic, if something happens, do this, otherwise do that. So let's create an RGB. So first create a red. So that's if someone comes in without scanning the alarm, it goes off. And yeah, you could actually do that. if you have the camera pair and the fingerprint. So let's make it red and create another one which will make it green. 255. Yeah, initiate lasers. 0, 2, 5, 5, 0. Press enter, and now draw this one in green. So I have something for feedback. So I need something with the finger. So finger read users with ID access. Finger get unknown. So if it's unknown, it will be this. And if it is someone with ID access, it will be green. Let's see how that works out. Okay, so now everything is removed and I have two loops. One which will show, create another one, make it black at the start. Run, see what happens. So it's black now, putting my finger on the device, and it is red. So red. Let's build in a timer. So adding a timer and make it copy, copy this one. So I have two loops. One will show red, wait for a second, and then show black. So let's try this again. So put my finger on red, and will be so put my finger on red, nothing, red, nothing. That worked quite well, but I need to enroll my finger somehow. So add user ID. I'm adding what I'm doing is I'm ending an event. So if the button A was pressed, then, so if I press the button on the M5 stack, finger 0, which is the device itself, will add user ID 1 with access 1. Okay, let's do this. So I'm putting my finger on the device and now I'm pressing the button. Removing my finger, putting it again. Oh, sorry. I was expecting this to do something. Add user ID access. Yeah, you can read it, watch it tomorrow. I will leave it online. Thanks for joining. Thanks for the interaction. I really appreciate that. So finger, add user ID, remove finger. So this should actually work. Get finger, get state, get access, get ID. Run it again. Oh, but there's a remove all on the top. So maybe I should remove this remove all. Okay, run it. Pressing the button, entering my finger, removing my finger. What is happening? Okay. There was a way to somehow interact with this device where you could actually see the variables. Remote, title, custom, advanced. Okay, finger 0, add user ID 1 to access 1. User ID, access finger, user ID. M5Stack. Don't know how it works. So go to the documents, go to what is it? Units. Go to fingerprint. Where are you? Thanks. Sleep well. Fingerprint. This one. So this is documentation. This is how it works. I need to connect to it. Setup. Create a loop and get the state. Let's moving this to another screen, so I'm able to reproduce it here. So first the setup. The setup turns it. Yeah, we'll look at the chat later. I create a loop. So this is a loop, and the loop like a simple loop logic. Event. Oh, loop. So run this one, loop. Label. Okay, I can create a label. So where's the label? Text. Oh, how do I do this again? I need to add a label. Not in here. Event. No. Can I just draw? No. Project. This one. Open setting. Bloxys. Add image. No. There's a resource manager. Examples. You already have examples. No. Forum version. New file. should be able to create a label. Oh, it's not possible to create a label because I have a blocky. Blocky only has text. Okay. So we'll get the state label. User ID. Yeah, this is actually how it should work. So if the button was pressed, actually it works. Red. So this one is green, and the other finger is red. Green, red, green, red. So am I able to enroll different fingers? So I'm accessing user 2. So this one is user 1. So let's make this one user 2. So pressing the button. Oh, this might actually need to restart it again. So press the button, train it on this finger. Come on, you can do it. Yeah, so this one is green. Was green. This one is green and this one is red. But let's see if I am able to still. Yeah, this one is green. This one is green. And this one is red. So I enroll 2 fingers now. So let's use a different thing. So if it's unknown, it will be red. And let's see if I have another event. So for the finger, finger, remove finger with ID, finger read user with ID access, read user with ID access. It's this one, yeah. Finger. So I need ID. So if let's create 2 logics. So if it is okay, it will be green. It will wait a while. So if, and this will be logic, if this equals that. So if get ID equals add math, so that might be either 1 or 2. So if it is 1, do this. Let's copy it and paste it. And if it is 2, do this. So if it is 1, uh, let's make a 1. Hey, thanks for the atom. Really like it. So, and if it is 2, let's turn this one into a 2. Let's see if this works. So run, and it is done. So go for this finger, should not do anything. This finger, if it is green, but what is the reason that this does not work? So wait for 1 second. Oh, I need to wait for another second to make this stay on the device itself. Let's make it 2 seconds. So it's probably too short on the screen. Is it done? Maybe run it again. Okay. Use this finger. Oh, the other way around. So 1, be able to see it. Let's turn the light on the. Where's my light? So, like this. A little bit blurry. So use this one. Not correctly. Does not recognize it yet. So won't put your alarm system on it. So this is 1. Use the other finger. And this is 2. So you will be able to recognize different fingers. Don't know what the limit is. Maybe look at the finger device. What is it? Tell me. Click on it. Oh, it might be this one. Okay. So how many fingers can you actually enroll? Oh, 150 different fingers you can enroll. So that's application resources. So 150. Okay, anyone else want to see something or try something before I go to sleep? GPS would probably not work inside the house. There's quite a large repository of the different devices that you can use with sample code already. There's schematics on, yeah, there's lots of possibilities. So you're only limited by the creativity of your mind. So there's lots of games you can imagine. I myself like to use it for prototyping. So actually use it for red teaming. So you can create a very small device that is able to either capture or clone simple UIDs on MyFair cards. Yeah, and a bit of sleep might be a good idea. Yeah, I did record this. So if you go to Periscope, you will be able to scroll back to the beginning. So what we actually did, boss, was yeah, and LoRaWAN. I actually never worked on LoRaWAN, but yeah, setting up one on LoRaWAN might be fun. What I did was show how you can use the atom to create like a dice by pressing the button and yeah, creating a random value and print like 126 on the device. And I showed some of the stuff that I already have to see what you can do with the M5 stack. But LoRaWAN would be fun. Might be fun to rebuild the phone again to show how that works. Do maybe start a Mario on the M5 stack with the faces shield. Yeah, lots of possibilities to do. We can program it in C using the Arduino IDE to program it, so you can actually program it using the M5Flow, using MicroPython, and using C or Arduino IDE. So I'm taking off for now. So for the people that joined later, you can scroll back the entire stream to see what I did, and I will do another one. Seems to attract a lot of people that are interested in this stuff. I think it's a cool platform to work on. M5Stack, and they really listen to their audience by creating new stuff, like the PLC stuff, and they have like new stuff for creating aluminium rails to do stuff like 3D printing, laser engraving, other stuff, and like making these ones like the bricks that allows you to switch heavy AC voltages. Yeah, is fun and safe for people. So I'm taking off. Have a nice evening, everybody, and thanks for joining the stream.